This command say move dot long a number to D6. And then after that, this is another name, sub dot long 1. You have to minus up D6. This number, D6 minus 1. So means that 84614 minus 1. Okay, 1, D6. And then after this one, branch not equal. What does it mean? Branch not equal del 1. Very simple, this one say that if my Z flag is still equivalent to 0, I still have to branch to del 1. So V and E, look at the V and E for the slides. V and E say, I must branch if my Z is equivalent to 0. I mesti branch here. Branch means you go to that label, go to that branching. So now Z is equivalent to 0, I have to branch. Okay, what does it mean? After you move this big number, 8,000, 84, 6,000, you are going to minus up 1. So you have to imagine that, you have to remember, I have to imagine that this, a very big number, you have to minus 1. Then you check here, if your Z is still equivalent to 0, you still have to branch to del 1. Go here again, do the same process until it finish. If your Z is equivalent to 1, then you are going to go up from the branch completely. So look at here. If you run 1 by 1, it's not going to finish. Here, you see? We have to 1 by 1, right? Very long because it's 84,000. I have to do it 1 by 1. So to make life easier, change this number to only 3. Because this is for simulation, and just change it to 3. Just now we are slow, we are not processor. That processor is very fast, 1 gigahertz. So it's very fast, we have to process it. We are not going to catch that one. So change it to 3. For your simulator, we want to show what happened. So change it to 3. Yes, you have to understand that. I have to show that one. So make it slowly. Okay. So now I go here, jump to subroutine delay, you will jump. Okay, this command say move dot long only 3. Right? 3 to D6. Look at D6 over here. You change here, okay? Move that one to D6. My D6 now is number 3. Betul, right? That command is correct. The next command say sub dot long only 1 from D6. Means that 3 minus 1 will be 2, betul? So what happened now? If that process done, your D6 will be going to be 2. Your Z flag is still 0. That's why they call it here. Branch not equal means that you will check the Z condition there. If Z is still equivalent to 0, you must branch to this one. So you will go back to this one, correct? Branch here to del 1. This is del 1, so it will go up again. You hit another button. You will go back there. Look at here now, it's still 2, right? 2 you have to sub again. Another 1. 2 minus 1, 1. Your D6 is equivalent to 1. Your Z is equivalent to what? 0. Z equivalent to 0 for B and E, branch not equal. If Z is still equivalent to 0, you have to branch again to del 1, complete it. So now you go back here. Agree? Right. So now D6 still number 1. Sub 1 from D6. Now what happened now is your register going to be 0 already. Okay, 1 minus 1 is equivalent to 0. Now your Z flag is equivalent to 1. It does not stop. It has to branch out. You will not branch again this one. You have to go down. It has to go up from the branch. So once B and E Z is equivalent to 1, if there's no more 0, so you have to go up from the branch. So what happens now? You will go down. So next one is going to be here. Correct? So it's going up from the loop already. This is the loop just now. Just imagine just now I put 100,000 and 900,000. You have to remember that you have to go here, wait until it's 0, then you go out. So it means that here, the last one, this command is to return to subroutine. What does it mean? That it has to return back to the main program before it jumps. So before it jumps just now, it's from here, correct now? Jump to subroutine, the pair will be the return to subroutine. So the last one, it jump from here. Now after this command, it has to go back to the main program, which is this one. So if I hit another button, it will go to this one. Move.byte F0. So what happened now? This is going to change your LED again. Swap the LED. Is it true? Yes, it's correct. Just now here, right? So it means that here is to turn on this LED, wait for a while, and then after this one, you have to turn on this LED. It's a blink, it's a flip-flop like this. So what happened now? After this, jump to subroutine again. It will go back to the delay. It's the same loop to make a delay. So again, you do the same thing. Done. Now you turn on this one. Can you catch that one? Here. You turn on this one. This is the delay. How long the delay? This one. The number here. Because it's a big number, you have to minus what? Yeah. Just now I put this one 3 only, right? 3 minus 1 is only 3 times only. If I put 900,000 minus 1, so how many?
I don't mean cycles per week. What is the seconds?
Seconds have to calculate based on the gigahertz that you have. There's a formula. Yes, different CPU got different gigahertz. That's why every cycle here must be maybe microseconds. So you have to time 900,000 to get that one. So different CPU, different things. But this one you have to use yours. So do you get it or not? Here. So the command that you need to learn over here is this one. You have to know that how to label it. Jump to subroutine. Jump to subroutine. Branch loop. Okay. Branch loop means after this delay, branch loop is a confirmed wajib. It's a must branch. No matter what. Conditional, this one will check the Z flag here. For branch is mesti. It's a must branching. without looking at this status register. So what does it mean here? After you complete this jump to subroutine delay, complete this one, go to a return to subroutine, you will go here. This command say you must branch. You must branch to loop. It will go up back here, do the routine all again. All the same again. Boleh tangkap? Can you get something? So the most important one here is about here. Be branch not equal. Branch not equal means as long as your Z is equivalent to 0, it must branch to that particular line. It must branch. You have to control it. So keep the program with you, because you're going to use it anyway. You have to understand it. Okay, that's the first command. That's the first code. Let's look at another code. Anybody still problem? Susah nak faham? So if you run continuously with these three number, you cannot see it blinking. That's why you add up this number to a bigger one. Just put any number, make it bigger. So the bigger number, you will have to make a time to minus it until 0. So the bigger number is the bigger delay, longer delay that you're going to create. So you can just put from 3, you can just put 9, 9, 9, 9, 9, 9, something like that. So you just can put like this. 9, 9, 9, 9, 9, 9. Just run it. And then you can see, you just run it. See? It's very long to delay. So I have to remove the number again, I make it smaller. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So view options, view hardware. You run it. Much faster. So I remove another number. I remove another number. I remove another one. Just remove it. Okay, run again. See, my blinking is getting faster because I changed this number. You just imagine that a bigger number, when you have to minus 1 by 1, it's getting longer. If you have a smaller number, you minus up 1 by 1, of course the time is shorter.
I think it is the number of the numbers, not the value. Because we put all zeros, it is same like 6 zeros, same like 9 zeros, 6 zeros.
Cannot be, cannot be 6 zeros. If you put 0, that's exactly 1 minus 0. You cannot put 0, right? Because the command next one is 0 minus 1. You cannot put 0. The command here is you have to look here. This is minus 1. 0 minus 1 is negative already. It's not 0. Which wrong? You have to put 1 side. Make sure it's a positive number. Okay, boleh? Boleh digest sedikit. So you have return to subroutine, you have jump to subroutine, you have branch, you have BNE. Ini benda baru to control a program. Okay, now look at another program. This is another one very important too. Okay, now look at here. Write down this one. can control your LED by using the switch. You run this one, then you run. Okay, now if you look at my result, just now I forgot to put n over here. Your code must be have n. Your code must have n. And you look at the result here. If I turn on my switch, it will turn on the LED. If I turn off my switch, it will turn off the LED. Now it does not really take care of the delay. Just now it's a fixed delay. Now I can control my LED by using switches. So make sure that you get that one first. Dapat? Can you run that? Make sure it's executable. Run this one. Is it okay or not? Look at the result. Yes. Make sure that you can use switch to control it. Make sure that you can run it. Make sure now. Boleh turn off? Boleh. Boleh. Okay. Dah jadi. Switch mana? Oh, switch tu kan? Bukan. Okay, switch satu kan? Switch satu. Bukan switch satu. Satu kosong. Oh, kau tak punya banyak. Tak. So, ni semua kosong kan? Kita satu kan? Kita play around with the test. Kat mana-mana. Apa? Buat yang boleh. Done it? You can compile it? Huh? Compile it? Make sure you can compile it. The color must be the same. Because the same thing have different color with it. You want to press another switch, then you want to change something. So which one? Huh? Okay. Okay. What's your hand? What's your hand? Okay, look at the code first. It's quite very simple code. Very basic codes, but different methods of writing. Okay, now I'm using equate. Equate means you are declaring it as a from the number to a name for easier, what do you call it? To make sure that you can program it easier. Because you can understand better in LED instead of you understand this one, right? LED is much better. It's very easy. So these terms is actually to declare. LED equate to this value. This is your hardware just now. Switch equate this value. This is at your hardware. Your hardware says your switch is at this address. E00012 is this one. E00010 is this one. Equate LED. So you know that this is the LED, this is the switch. Okay, you are declaring it. You are declaring it. Doesn't matter. Okay, now let's look at the program now. I refresh it. Yeah, run it again. The first command is going to move dot byte. Move dot byte 00 means you are going to turn off the LED, correct? Huh? So this is going to be moved to LED. LED is basically to this hardware. Then you are going to turn off it. So the command will turn off. Is it correct? So you will turn off all the LED. Okay? Initial condition I turn off. Now look at the command here. This is your main program. Okay, this main program will go and check the switch. If your switch is on, it will turn on the LED. If the switch is off, it will turn off the LED. The main, this is, I just put the name, is the main program, move dot byte, the condition of your switch to D6. So right now, my switch is off, correct or not? My current condition for the switch is 0. Okay, so I'm expecting it. So move the byte switch to D6. My D6 will all going to be 0, 0, 0, 0 because this is 0, 0, 0, 0, 0, 0, 0, 0. Okay, so I'm expecting it. My D6 will be 0.